Hi class. In this video, we are going to talk about the definition of a vector and how can we write a vector in component form and how can we calculate the magnitude of a vector. So first of all, vectors are used to represent real world situations like acceleration, force, velocity, and a vector is a directed line segment. It's a line segment with direction. For example, so then we can represent a vector AB, and we are going to name that vector AB. So A is going to be the initial point, and B is going to be the terminal point. Pay attention that in this case, the arrowhead doesn't mean that the vector keep on going forever. So that means that the direction of that vector is from A to B, but B is a terminal side. Remember, the arrowhead doesn't mean keep on going forever. Okay? So that means the direction of the vector. Another name for the initial point and the terminal point is that A is going to be the tail of that vector, and B is the head of the vector. So then the vector is heading in that direction. So that is the head of the vector. So since we reserve letters like x, y, z for variables, so we can also represent the vectors using the remaining last letters in the alphabet, like V, vector V, vector W, vector U, vector S, and so on. Now we are going to talk about an important information about vectors, the component of a vector. So how can we write a vector in component form? So in writing vectors in component form, is using the coordinates of the initial point and the terminal point. So in this example, the initial point P is at 2, 1, x sub 1 is 2, y sub 1 is 1, and then the point Q is located at 6, 4. This is x sub 2, y sub 2. And now we are going to write the component form. So vector PQ, so that is the direction of the vector, equals. Now we are going to use angle brackets. Angle brackets. No brackets, no parentheses, no braces, angle brackets. And inside the angle brackets, we have the horizontal distance x sub 2 minus x sub 1, comma, the vertical distance. So then y2 minus y1. So then the vector PQ in component form equals 6 minus 2, comma, 4 minus 1, now PQ vector equals 4, comma, 3. And that is the component form of the vector PQ. Another important information about vectors is the magnitude of the vector. The magnitude of the vector is nothing but the length of the line segment. What is the distance from P to Q? So that means that we have to use the distance formula. Vector magnitude. And we are going to represent the vector magnitude by using two parallel lines and the vector PQ inside those two parallel lines. So pay attention that in this case it doesn't mean the absolute value of PQ vector. So that means the magnitude of the vector PQ. It could be like this, or it could be by using a double parallel lines, right? In both ways. That equals distance formula. X2 minus X1 S squared plus Y2 minus Y1 S squared. Vector PQ magnitude equals 6 minus 2 squared, the difference of 6 and 2 squared, plus the difference of 4 and 1 squared, square rooted. So then vector PQ magnitude equals the square root. 6 minus 2 is 4, squared 16. 4 minus 1 is 3, squared equals 9. Magnitude of the vector PQ is the square root of 25. So then the magnitude of the vector PQ is the square root of 25, 5. So that means that the length of that line segment is 5. That is the magnitude of the vector PQ. Thank you.